Welcome to my YouTube channel Prakash Coaching Classes. Today we are going to continue the light refraction chapter. In this class we are going to study the image formation by lenses. In total there are 8 cases, 6 of convex lens and 2 of concave lens. So let's start study by convex lenses. First case, the object is at the infinity and the image form is at f2. So as you can see, the image form is diminished and point size, and the nature of the image is real and inverted. Moving on to the second case, the object is placed beyond 2f1 and the image form between f2 and 2f2. The image form is diminished, smaller in size as compared to the object, and the nature of the image is real and inverted. Third case, when the object is at 2f1. So the image form is also at 2f2. The size of the image is same size, that means the height of the object and the height of the image is same. Fourth, nature of the image is real and inverted. Fourth case, when the object is placed between f1 and 2f1. So the image form is beyond 2f2 and the image size of the image is infinitely large as compared to the size of the object, and the nature of the image form is real and inverted. Now coming on to the fifth case, the object is placed at f1. So when the object is placed at f1 of a convex lens, the image form is at infinity on the other side of the mirror, and the size of the image is infinitely large. It is a magnified huge image, and the nature of the image is real and inverted. Coming on to the sixth case, the last case of convex lens is that when the image is placed between optical center and f1. As we place the object between the optical center and the f1, the image form will be virtual and will be beyond 2f1. That means on the same side of the mirror, and the size of the image is enlarged and the nature is virtual and erect. Now we are going to discuss on the concave lenses. First case of concave lens, when the object is placed at infinity, the image form will be on f1 on the same side of the mirror of the lens, and the size of the image is point size and the nature of image is virtual and erect. Coming on to the second case, when the object is placed between f1 and 2f1, the image form will be between optical center and the f1, and the image will be diminished, smaller in size as compared to the object, and the nature is virtual and erect. Let's discuss the sign convention for lenses. In lenses, we measured all the distances from the optical center. As we measured in mirror all the from pole. Here instead of pole we are measuring it from the optical center O. Second important point is that sign convention is same as in case of mirror. What this conventions we have discussed in the mirror will be applied same in the lenses too. Second topic, lens formula and magnification. In mirror we have mirror formula, in lenses we have lens formula. So lens formula states that 1 upon v minus 1 upon u equals to 1 upon f, where u, v, f represents the image distance, object distance and focal length. Next is magnification. Magnification states that height of the image divided by height of the object is equals to v upon u. That means image distance upon object distance. Now let's understand the mirror lens formula with the help of an example. A problem statement is a concave lens has a focal length of 15 cm. At what distance should an object be placed so that it forms an image at 10 cm from the lens? Also find the magnification produced by the lenses. So in this problem we have been given the image distance and the focal length. So with that help, by applying the lens formula, we will obtain the image distance, and subsequently using the image distance and the object distance we will find the magnification. and then finding the magnification, we can comment on the nature of the image. So these are the steps by which we will solve the problem. So since it is a concave lens, in concave lens we know the object is all, the image form is v is -10, focal length is always negative in the concave lens, and by applying the lens formula we will get the image distance will is -30 centimeter. So with -30 centimeter, it is clear that the image form is on the left hand side of the mirror lens. Putting the values of v and u in magnification formula, we will get magnification is 0.33. Now focusing on the magnification, we will get to know that the height of the image is lesser as compared to the height of the object. So the image form will be erect and virtue. On to the last topic of the chapter, power of lenses. Power means it is a reciprocal of the focal length. But here an important point to be noted is that focal length should be in meter. Should not be kept in centimeter. Here for calculating power, the focal length required is in meter. So it is a key point to note. Second point, the SI unit of power is diopter. It is represented by capital letter D. Third point, the power of convex lens is positive and the power of concave lens is negative. It is because in convex lens the focal length is positive, and in the concave lens the focal length taken is negative. It is due to which the power comes positive and negative. Last but not the least, an important point, if we combine few lenses, let's say 4 lenses, 3 are concave and 1 is convex. So and we have to find the power of the combination of these lenses. So what we needs to do, we need to calculate individual powers and then do an algebraic sum of that. By doing that, we are able to obtain the power of combination of these lenses. So thank you for watching this video. Do subscribe, like and share this video. Thank you.